Let's take a look at these questions from sequences and series. Question 2 reads, given the arithmetic series 5 plus 7 plus 9 plus and so on up to plus 93, determine the general term Tn in the form Pn plus Q. So we can start off quickly by using our formula 2.1.1. Let's look at our series first. So 5, 7, 9. We can see that the difference here and here is 2, right? So D is equal to 2. And so we can use the formula Tn is equal to A plus D into n minus 1. A is the first term, so 5, plus the difference, which is 2, open bracket n minus 1. We can then simplify really quickly. So we're going to get 5 plus 2n minus 2. And then lastly, simplifying, getting 2n plus 3. Moving on to question 2.1.2. The given series represents the number of kilometers that an athlete ran each week in preparation for an ultramarathon. The athlete ran 93 kilometers in the last week of the training program. How long in weeks was the training program? So if you look at this, the question, what we can do is we can say that's week 1, that's week 2, that's week 3. We want to know what week this is. So in other words, we want to solve for 93. We want to solve for n. So we'll say that 93 is equal to 2n plus 3. Then 90 is equal to 2n. N is equal to 45. So there's been 45 weeks that the athlete has been training for. Question 2.1.3 reads, the athlete used this opportunity to raise funds for her high school. The community sponsored her 10 rand for every kilometer ran or kilometer run during this training program. Calculate the total amount that the athlete raised for her school. So we want to know in this 45 weeks, right? In the 45 weeks, what's the sum of these numbers? So we want to work out the sum to 45. Now the sum to 45 is going to be n over 2 into a plus l. So n is 45, so 45 divided by 2. A is our first value, so 5. L is our last value, 93. And then we can solve. So 2205. So this is now the total number or the sum of the kilometers. But we want the total amount of money, so we need to multiply this by 10. So 2205 multiplied by 10 gives us 22,050 rand. Okay, question 2.2. Question 2.2 reads, the general term of a geometric sequence is Tn equals 2 to the power n plus 2. Write down the first term. So the first term is when n is 1. So Tn is equal to 2 to the power 1 plus 2. That's 2 to the power 3. That's 8. B, the common ratio. To get the ratio, it's T2 divided by T1. T2 is going to be 2 to the power 2 plus 2 divided by T1 we worked out is 8. So 2 to the power 4 is 16. 16 divided by 8 is 2. So our common ratio is 2. Question 2.2.2. Calculate T20. Write your answer as a power of 4. So T20 is going to equal 2 to the power 20 plus 2. That's 2 to the power of 22. Now we can rewrite this as 2 to the power of 2 to the power of 11. 2 to the power of 2 is 4, so 4 to the power of 11. 2.2.3. Calculate this sigma notation. So 1 over Tn from when n is 1 to n is infinity. Now let's just quickly rewrite this. So we have our sigma notation here. N is equal to 1 up to infinity, and then 1 over Tn. So Tn, remember, is 2 to the power of 2, or rather 2 to the power n plus 2. Now what I want to do is I want to just separate this. So I can rewrite this as, so again, the sigma notation, n is equal to 1 up to infinity, And 2 to the power of n plus 2 can be rewritten as 2 to the power of 2 multiplied by 2 to the power of n. So 1 over 2 to the power of 2 times 2 to the power of n. Now I can take this out since it's a factor, right? It doesn't have any variables in it. So my sigma notation now is n is equal to 1 up to infinity, and I have a quarter out front here, and then 1 over 2 to the power of n. Now we want to evaluate this part. Okay? So we're going to have a new sequence here, a new series. So let's work out our new series. So our new series is going to be 1 over 2 to the power 1. So that's 1 over 2. Then plus 1 over 2 to the power 2, which is 1 over 4, plus 1 over 2 to the power 3, which is 1 over 8, and so on. So 1 over 2, then 1 over 4, then 1 over 8, and so on, until we go up to infinity. So how do we evaluate this? So first thing we want to do, let's figure out what the ratio is. So the ratio we can see is going to be half. So we're multiplying by half each time. And so we can work out the sum to infinity, right? And the sum to infinity is going to be, so sum to infinity is going to equal a over 1 minus r. A is my first term, which is half in this case, divided by 1 minus, and r is half. So the sum to infinity is going to be 1. So this value goes here. So my final answer is going to be a quarter times the sum to infinity. So a quarter times the sum to infinity was 1, so the answer is a quarter. Okay, let's move on. Question 2.2.4. 2.2.4 reads, consider the first 21 terms of the sequence Tn equals 2 to the power n plus 2. Calculate the sum of the terms in the sequence that are not powers of 4. Okay, so let's first figure out what terms are going to be powers of 4. So let's see, term 1, that's going to be 2 to the power 1 plus 2. That's going to be 2 to the power of 3, which is 8. That is not a power of 4. T2, that's going to be 2 to the power 2 plus 2. That's going to be 2 to the power of 4. That's going to be 16. That is a power of 4. That's actually 4 squared. T3, that's going to be 2 to the power of 3 plus 2. That's 2 to the power of 5. That's 32. That is not a power of 4. And let's just do one more. So T4, that's going to be 2 to the power of 4 plus 2. That's 2 to the power of 6, which is 64. That is 4 to the power of 3. So we notice that the powers of 2 are going to be even values. So we're not going to focus on the even values. We just want to focus on the odd ones, because those are the ones that are not going to be powers of 4. So let's look at our new series. So we're going to have T1, then we'll have T3, then we'll have T5, and then we're going to go on all the way to T21. Now, how many terms are there going to be here? So what we can do is we can work out the number of terms if we just focus on these numbers. So 1, 3, 5, 21. So if you just focus on those, 1, 3, 5, 21, you can see here the difference is 2. So Tn is equal to 1 plus 2 into n minus 1. There are 21, so 1 plus 2 into 2. Rather, we're solving for n. Yeah, let's solve for n. So Tn is equal to 1 plus 2n minus 2. Tn is equal to 2n minus 1. Now, if we want to know how many terms there are going to be, so let's substitute 21 in. So 21 is equal to 2n minus 1. 20 is equal to 2n, n is equal to, 22 here, and then n is going to equal 11. So that means there are going to be 11 numbers. So 1, 2, 3, and this is going to be the 11th number. So our sequence is actually going to be, the first term was 8, the next one was 32, then 64 was a power, then 128, which is 2 to the power of 7, that's not going to be a power. So we'll go 128 here. And we can see that each time you are multiplying by 4. So this is gonna be a geometric sequence where you have Tn is equal to a times r to the power n minus 1. So a is 8 times 4 to the power n minus 1. Now if we want to know if we are adding all of these numbers up, and you're adding it up to T21, whatever that T21 is, right? What's the sum going to be? So if you have a sequence like that follows this pattern, then the sum of it is going to be Sn is equal to a into r to the power n minus 1 all over r minus 1. Now, we figured out at the beginning that there are going to be 11 numbers that's going to be odd from the first one to the 21st one. We worked it out is 11. So we're working out the sum of those 11 numbers. So the sum of those 11 numbers is going to be a, which is 8, into r, we worked out as 4, to the power of 11 minus 1, all over 4 minus 1. So S11 is equal to 8 into 4 to the power of 11 minus 1 divided by 3. That's quite a large number, so I suggest we just leave it like this. Okay, let's move on. Question number 3. Given the quadratic sequence 14, 9, 6, and 5, show that the general term of this sequence is Tn equals n squared minus 8n plus 21. So let's just write it out really quickly. So 14, 9, 6, and 5. You can see here that you are decreasing by 5, you are decreasing by 3 here, and you are decreasing by 1 here. Now the difference here is going to be minus 3 minus minus 5, which is 2, and then minus 1 minus minus 3, which is 2 again. Now remember, 2a is equal to this value, 3a plus b is equal to this value, and then a plus b plus c is equal to this value. So let's start. We can say that a is equal to 2 divided by 2, which is 1. Then 3 into 1 plus b is equal to negative 5. B is equal to negative 8. And then the last one, a plus b plus c, a is 1, b is negative 8. So 1 minus 8 plus c is equal to 14. So 1 minus 8 is minus 7 plus c is equal to 14. C is equal to 21. And therefore we got our answer, Tn is equal to n squared minus 8n plus 21. Let's look at 3.2. Two consecutive terms of the quadratic sequence have a difference of 33. Calculate the value of the larger term. Now what you want to do here is you want to say that Tn plus 1 minus Tn is equal to 33. Now Tn plus 1 will be n plus 1 squared minus 8 into n plus 1 plus 21 minus Tn. So n squared minus 8n plus 21, and that's equal to 33. Now let's expand and then simplify, and then we solve for n. So this will be n squared plus 2n plus 1 minus 8n minus 8 plus 21 minus n squared plus 8n minus 21 is equal to 33. Now let's look at what we can cancel here. We can cancel the n squared. We can cancel the negative 8n, the minus 21, and we will be left with 2n, and 1 minus 8 is minus 7, and that's equal to 33. That means 2n is equal to 40, and n is equal to 20. So the Tn will be T20, and Tn plus 1 will be T21. So they want to know what is the value of the larger term. So we want to work out what is T21. So T21 will be 21 squared minus 8 into 21 plus 21. That's equal to 294.